Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code DTC P2422 indicates a malfunction involving the EVAP canister vent shut valve, specifically that it is stuck in a closed position. In Honda vehicles, particularly the 2015 to 2020 models of the Honda Fit, this part plays a critical role in the evaporative emission control system, EVAP. It helps manage fuel vapors by opening to allow them to vent, thus preventing excessive pressure buildup in the fuel tank and system. If this valve is not functioning as intended, it can lead to poor vehicle performance, increased emissions, and potentially trigger a check engine light. Given the importance of the EVAP system in handling vapor emissions and safeguarding against fuel leaks, diagnosing this trouble code promptly is essential. The troubleshooting process involves several steps aiming to validate the malfunction and assess various interconnected components of the system. The DTC P2422 points directly to a problem with the EVAP canister vent shut valve, which is a vital component in controlling the flow of fuel vapors from the fuel tank to the engine for combustion. The valve is usually located on or near the EVAP canister, situated beneath the vehicle, often on the rear side near the fuel tank. This component closes to prevent fuel vapors from escaping into the atmosphere when the engine is not running, and opens when the engine is operating to allow controlled venting. When malfunctioning, the valve being stuck closed can disrupt the entire purpose of the EVAP system, leading to various performance issues. The location of the valve is important for technicians diagnosing the issue, as accessibility will dictate the ease with which they can perform repairs or checks. Several factors can contribute to the P2422 DTC being triggered, starting with electrical connection issues. This can include poor or loose connections between the EVAP components and the vehicle's powertrain control module, PCM. Another significant cause can be corrosion present on the vent shut valve itself, which can impede its ability to open and close correctly. Blockages within the vent lines or hoses leading to and from the EVAP canister can also trigger this code, as they limit the normal flow of vapors. Each of these possible causes affects the EVAP system's efficiency, leading to potential increases in emissions and triggering the check engine light. Thorough investigation of each component and connection is crucial in identifying the underlying issue affecting the system. When the P2422 code is active, several symptoms may become noticeable to the driver. One of the most immediate indicators is that the check engine light, CEL, will illuminate on the dashboard, indicating a malfunction within the emission system. Additionally, drivers may observe a decrease in fuel efficiency, as the EVAP system's malfunction can lead to improper fuel vapor management. Another symptom that may present itself is difficulty filling the gas tank. This occurs when the vent valve fails to open, creating a vacuum that prevents fuel from entering the tank smoothly. These symptoms not only impact driving comfort and convenience, but may also lead to more severe mechanical problems if not addressed promptly, as they highlight a failure in the vehicle's emissions control system. The first step in diagnosing the P2422 DTC involves checking the evaporative emission control EVAP system. Start by turning the vehicle to the on mode, which powers up the vehicle's systems without starting the engine. Following this, clear the DTC using the Honda Diagnostic System, HDS, as this will reset any error codes stored in the system, allowing for fresh diagnostics. Remove the fuel fill cap and allow it to sit for approximately 1 minute. This action will help release any pressure built up in the fuel system. After waiting, turn the vehicle back to the on mode and check specific parameters, notably the fuel tank pressure (FTP) sensor readings. This systematic approach sets the groundwork by confirming the presence of the DTC and determining if further issues exist. In the second troubleshooting step, it is crucial to confirm whether the original malfunction persists. After completing the initial checks and actions, reinstall the fuel fill cap securely. Again, clear the DTC with the HDS, as this prepares the system for a new diagnostic cycle. Next, start the engine and allow it to idle, ensuring the transmission is in park or neutral for automatic models, and neutral for manual transmission models. Keep the engine running until the radiator fan comes on, which typically indicates that the engine is reaching an operational temperature. While idling, monitor the EVAP purge control, PC duty, through the HDS, particularly at approximately 3,000 RPM, with the PC duty set at 20% or more for at least 4 minutes. This step helps assess if the EVAP system is properly functioning. If the HDS indicates a failure, further investigation is warranted. Step 3 involves checking the EVAP canister vent line for blockage or faults that may trigger the DTC. Begin by clearing the DTC with the HDS once more, allowing the diagnostic system to reset. Turn the vehicle to the off mode and disconnect the EVAP canister vent hose from the vent shut valve unit. This allows for more precise checks on the venting aspects of the system. After disconnection, switch the vehicle back to the on mode and analyze the values displayed by the HDS for the FTP sensor. The expected range is between -0.67 kilopascals. Should the parameters fall within this threshold, further analysis is required to check for any potential blockages in the hoses or the vent line itself, as these could cause the valve to operate incorrectly. In the fourth troubleshooting step, attention turns to the EVAP canister vent shut valve directly. Begin by placing the vehicle to the off mode to ensure safety while working on electrical components. Proceed to remove the vent shut valve from the EVAP canister, carefully ensuring that no debris or damage occurs to surrounding elements. Once removed, connect the 2P connector back to the vent shut valve. Turning the vehicle to the on mode will power the valve and allow for conduct tests. Utilize the EVAP testing function in the HDS, selecting the EVAP CVS on in the single solenoid mode to check the operation of the vent shut valve. Inspect the valve thoroughly to confirm it is free of corrosion and operates smoothly. If both conditions are met, this indicates that the valve itself is functioning correctly. Should there be any signs of corrosion or function failure, it is necessary to replace the vent shut valve. The fifth diagnostic step involves verifying the functionality of the FTP sensor vent hose. Disconnect the vent hose from the FTP sensor to allow for accurate readings and checks. After disconnection, analyze the FTP sensor's readings displayed on the HDS, ensuring that they still reflect the expected range of -0.67 kilopascal. If the parameters are correct, focus your investigation on potential blockages along the FTP sensor vent hose. This blockage could inhibit proper readings and cause miscommunication within the EVAP system, leading to poor performance. Should any obstruction be found, addressing these issues will be vital before moving forward with further diagnostics or repairs. In the final troubleshooting step, focus shifts to the FTP sensor itself. To start, turn the vehicle to the off mode and then remove the FTP sensor from the EVAP canister while keeping its connector connected. This approach maintains connections while allowing you to check the FTP sensor functionality. After removal, power the vehicle back to on mode and monitor the relevant parameters on the HDS again. Similar to previous steps, confirm that the FTP sensor values reach the expected criteria of -0.67 kPa. If they do, it indicates that the FTP sensor port remains functional. However, if the values fall outside this threshold, replacing the FTP sensor is necessary because it is likely malfunctioning. Continuing these checks ensures that each component within the EVAP system is properly evaluated. Once all repairs and replacements are made, it is crucial to verify that the issues have been resolved successfully. Begin by meticulously checking all electrical connections made during the repair process, ensuring that no wires are frayed, loose, or improperly connected. Next, clear the DTC using the HDS again, as this resets the monitoring system. Follow up the clearing process by taking the vehicle for a test drive under conditions that might trigger the P2422 code, monitoring performance carefully. During this test drive, observe the functionality of the EVAP system and ensure that the check engine light does not reappear, confirming that the repairs were effective. Proper verification ensures that the fixes made are reliable and the system functions as intended without further issues. To prevent recurrence of issues related to the P2422 DTC, regular maintenance on the EVAP system is crucial. Schedule routine inspections of the EVAP components, particularly focusing on the vent shut valve, hoses, and sensors involved in the emission control system. Maintaining cleanliness in electrical connections helps avoid corrosion and ensures proper functionality in the system. If any wear or damage is observed, such as cracked hoses or corrosion on the vent valve, replacing these parts promptly will enhance long-term reliability and performance. These preventive measures are instrumental in extending the life of the EVAP components and minimizing costly repairs down the line. In conclusion, understanding the components and function of the EVAP system will significantly aid in diagnosing issues like DTC P2422. By recognizing the common symptoms, including the check engine light, poor fuel efficiency, or difficulty filling the fuel tank, you set the stage for effective troubleshooting. Following the outlined steps meticulously directs you to potential issues within the system, whether concerning electrical connections, valve malfunctions, or blockages. Swift diagnosis not only leads to quicker resolution, but also helps maintain vehicle performance and regulatory compliance. Overall, an informed approach to troubleshooting DTCs fosters better outcomes in vehicle maintenance and repair efficiency. Please like and subscribe to the channel. See you next time.